Bonjour, kia ora koutou. I'm Nick Cameron. I'm here to talk about Rust format. I'm known online as NRC, and you might recognize me from the avatar. I've been involved with Rust since before 1.0. Relevant to this talk, I started the Rust format project and did much of the initial work on that, and then started and led the style team, so I have some biases here. I'm currently a freelance engineer and consultant on Rust stuff, so it's the website, you can hire me. I'm going to assume that you're all committed Rust format users and adherents to the universal Rust code style, so you don't need persuasion, but I think it's useful to go over like why we might want to do formatting at all. For an individual developer, having a formatting tool, it saves you effort, and it saves you having to worry about style as well, which is nice. When a whole project or a whole team adopts a single code style and an automatic formatter, you get more benefits. It saves a lot of effort for reviewers. They never need to worry about pointing out style issues because that's caught in CI, and so they can focus on the important stuff. It also saves you a whole bunch of arguments about what code style you're going to use in the project. But I think the biggest benefit comes from when the entire ecosystem opts into a single code style and an automatic formatter, because then you get this superpower that you can go to any project, whether that's one of your upstream dependencies or whether it's a crate you want to evaluate or just something you want to hack on at the weekend, and you immediately feel at home with the code style. Because learning a new code base is really difficult. You don't need to make that harder for yourself by having this kind of constant low-grade cognitive dissonance of an unfamiliar code style. Which is great, but formatting is actually kind of difficult, which I guess might be a bit surprising. To explain why, I want to start with just the size of the domain. I'm going to use function declarations as an example. And as I go through some of the syntax, pay attention to how the formatting changes. So Rust has function declarations. This one has an empty body. This one, you can imagine, has some code in the body. This one has no body at all. A function can have a return type, which can be arbitrarily complex. It can have privacy modifiers, which can be parameterized. It can have an attribute. It can have argument, which can have a type, which can be arbitrarily complex. You can have multiple arguments. You can actually have an arbitrarily complex left-hand side of the argument too. You can have generic arguments, which can have bounds, which can be arbitrarily complex. And you can write those inline in the argument types if you prefer that. You can have lifetime arguments. You can have constant arguments. You can have a mix of all of those. They can all have bounds, or you could write those bounds separately. And that's just function declarations. There's also inline and out-of-line modules, 3 kinds of structs, enums with 3 kinds of variants, trait declarations, impl declarations, and so on and so forth. And that's before you even get to expressions and statements, which are actually the hard thing to format. Take this statement, for example. This is relatively simple, relatively common kind of statement, relatively small. There are 17 places that you might reasonably insert a line break here, which means that there's 131,000 different ways to format this small statement. And you might argue that a bunch of those formattings would be ridiculous, and you'd be right. But there's also a bunch of sensible formattings, like this one, this one, this one, this one, this one, this one. No, this one is actually misleading. This one I would classify as a bad formatting, but it's kind of hard to teach a tool that. And we're kind of getting at one of the real issues with why formatting is difficult, is how do you choose between those different formattings? Just getting within the space available is not good enough. It has to look good too. And in fact, it has to look great, because developers are really fussy about how their code looks. And this is just all aesthetics. A lot of it is totally subjective. So for example, which of these two formattings is better? This is not a trick question. This is tabs versus spaces. We've been arguing about this one for decades, and you can't even see the difference, right? So a few more reasons why formatting is difficult is because you can't change the meaning of the code. This would be really bad to do. How hard can that be? All you're doing is changing the white space, you might argue. Well, it turns out that's not all you're doing. So for example, if you've got a expression statement that looks like this, you might want the formatter to do this. But then people will argue that it should have a trailing comma. And so we're doing more than just white space. And if you do the reverse of that, then people would argue, and they would be right, that you have to take that comma out or it looks really ugly. But just changing a trailing comma can change the meaning of the code in several ways. And there are many other ways that reasonable people might expect a code formatter to do more than just change the white space. So for example, where order doesn't matter, they might want parts of your code to be ordered alphabetically. You might want to insert or remove code blocks. More trailing commas there. And in 2017, we thought it was important that we replace the try macro with the question mark operator, which was kind of new at the time. And even if you don't break the semantics of the code from the compiler's perspective, developers will use the formatting of their code to suggest kind of the implicit semantics. So for example, this suggests that this is a 3x3 matrix, and if you format it like this, then developers will get angry. Another reason that formatting is hard is comments. Comments can be anywhere, like really anywhere, pretty much between any two tokens in the source code. And they are one of the places that white space is significant. Be careful about white space around comments because you can break code quite easily. And again, even if you manage not to break the code, you can change the meaning of the comment. And as if that wasn't enough, the bar for success is really high. Like as I said right at the beginning, we really want everyone in the entire ecosystem to use your one style and your one formatter. That's a pretty high bar for success. Now, you might have noticed as I went through some of these issues that some of them are kind of technical issues and some of them are really social issues. And this talk is really about both of those things, and it's about how those things intersect, and it's about kind of, sort of, how we have some technical solutions to social problems. So let's talk about what we did, and I'm going to start with talking about the style RFC process, which was how we designed and decided on a single Rust code style. We thought it was important to separate out kind of specifying that style from implementing Rust format. In the same way that we have separate teams to deal with Rust's language design and implementing the Rust compiler, we wanted to do the same thing with the style. We wanted everybody to be able to have a say in the style without having the barrier to entry of having to implement it in Rust format. By doing this, we can get like much wider input, and the hope is that that will give us not only a better result, but more acceptance by the community when we're done. So this process, we used the tools, the governance tools that were available to us. We adopted the RFC process. The RFC process is the primary mechanism for discussion and decision making within the Rust project, and we adapted that into a kind of mini RFC process specifically for working on the style. We started a style team, and we had to juggle a little bit with what a team was, because this was before we had working groups in the project, and we only had these pretty big, serious teams like library and language, and the style didn't really kind of like fit into that. But we had this idea of having these teams that were very tightly constrained in terms of scope and duration. And we tried to precisely define the the process for decision making up front, because we were pretty worried that this process would just drag on and not be productive, not unjustifiably, I think. So I think importantly, we followed community norms and values. The style team was open to volunteers. Discussion was open to everyone. Decision making was mostly done in public, asynchronously on GitHub. And the synchronous meetings we did have were minuted and reported. Decision making was consensus-based. We didn't vote. I led the style team, but this was more of an organizational role rather than having a veto or being kind of a style BDFL. Discussion was thorough. We strived for objectivity where we could, and we did things. We defined and applied kind of a prioritized set of principles, and we experimented, for example, by applying perspective styles using Rust format to very large examples, so that we really kind of experienced using the style. We weren't trying not to just guess. All right, gonna change gears a little bit to talk about how a formatter would work. I told you this was kind of 2 talks in one, right? An automatic formatter, basically very high level, looks like this. You read code in, you process that code to build up information about the code, and you make your internal representation. And then you use that internal representation to format the code and write it out, and hopefully it looks prettier. And the design space is really defined by these 2 bits. It's what your internal representation looks like, and the algorithm that you use for turning that into formatted code. For the internal representation, one option is you just use plain text. I mean, you need the plain text somewhere, but that's not super useful. More common is you use a tokens view, where a token is just a small atomic chunk of the program. Every bit of punctuation becomes a token. Every keyword or identifier is a token. With this approach, you need a bunch more information, though. For example, you want to know about matching parentheses when you're formatting. You need to know something about the precedence, so you can choose the better formatting in examples like this. And an alternative is, rather than using just tokens, is that you go one step further and use an abstract syntax tree. So this is a really common data structure that compilers use. Has all that information about scoping and precedence and so on built in. The problem with that comments, as I mentioned earlier, comments make this really hard, and there is no way or no good way to integrate comments into an AST. Compilers don't need comments, but formatters very much do. Either way, you're going to want to store a bunch of information, more than just this kind of like basic representation of the program text. I think it's kind of interesting to divide this information into 2 kinds. So you can have information that's purely about the meaning of the program. So for example, you might note that, hey, I've got this code block, and this code block is actually the else block of an if-else statement. Or alternatively, it's part of like a struct declaration or something, because you might treat that differently when you come to formatting. As well as, or instead of that, you might record information that's more directly related to formatting. So you might say, these 2 tokens, they have to be kept right next to each other, never separate. Or here's an opportunity for a line break, and here's how much weight I'm going to assign that in my decision algorithm. Then how you generate the output, it's closely tied to the representation you're using, but essentially you walk that internal representation, whatever it is. As you do that, you build up more context about the program. So you might note that, hey, I'm formatting an expression which is part of an argument list of a function call, and the current level indentation is this much, and what circumstances would I back off that indentation, and so on and so forth. You're going to follow a set of rules, and these rules are ultimately what defines the code style. And these rules might be kind of explicit, hardwired into your formatting algorithm, or these rules might be actually part of the internal representation that your formatter has. And then either way, whatever algorithm you use, you're going to try not to backtrack, or equivalently, not explore too many different options, because the more you do that, the more fan-out you have in your search space, and that's really bad for performance. Okay, so what does Rustformat do? And to really explain why it does what it does, it's important to revisit some of the requirements on Rustformat. So we decided that Rustformat ought to be really highly configurable. Now, in the end, you want everybody using the same style, but as a pragmatic requirement, having configurability makes it easier for people to adopt Rustformat. Or for the style team to experiment with different styles, and it kind of takes the edge off any conflicts around, the decisions on what style you're going to go for, because there's always an escape hatch. We needed Rustformat to be flexible, and Rustformat started before the style team and the style RFC process, but essentially kind of like they developed in parallel. And so we didn't know what style we would end up with. We had to have quite an open mind about supporting different kinds of styles, and we didn't want technical decisions in Rustformat to kind of close the doors for the style team and their styles they use. So flexibility was really important. And we thought that stability was really important. Like if Rustformat was changing how it formatted a lot, if it was doing lots of bad formatting, or if it broke your code, then it would frustrate early adopters. We'd get a bad reputation. It would harm our uptake. So this was a priority for us. So the implementation we chose to use RustC's AST. This gave us a little bit of a head start because it meant we could reuse their parser and AST without having to write that ourselves. It gave us kind of maximum flexibility because it gave us so much information about the structure of the code. And it also helped with accuracy because it meant that Rustformat had the same view as the program code as RustC has. For the formatting algorithm, I would describe it as kind of a low abstraction approach. So rather than trying to abstract the problem of code formatting into something like a graph search problem or solving kind of an algebraic system or something like that, we walk the AST and we have a bunch of relatively straightforward if statements, essentially, and dealing directly with, hey, we want to line break here or indent here. This meant, again, that we could be very flexible, like we could handle very different kinds of formatting. On the left is kind of where we started the style process, and on the right is where we ended up, and Rustformat can handle both of those and a lot of in-between as well. And it also made it really easy to make Rustformat very configurable. It also, it meant that the code base was quite easy to learn, and this is really important for an open source project like Rustformat, where you're reliant on contributions from volunteers. So how did it all go? I'm going to start by thinking about Rustformat, and I think most importantly there is we shipped Rustformat 1.0 as part of the 2018 edition, so that was on schedule, and it worked, so, that's a success. The output is, I think, pretty good. We delivered the code style that the style team specified, and it's most of the time implemented pretty well. And it's a pretty versatile tool. You can use Rustformat from the command line inside an IDE, in CI, and so on. And there are very few code bases where Rustformat just falls over and doesn't work. On the other hand, it could be faster. I think it's really performance is really important for developer tools, and especially on a large project or even kind of a large complex file, Rustformat is not instantaneous at all. Maintenance is a bit of a pain because it's highly configurable, because we use the AST as the IR, there's a lot of code. Excuse me, and there's a lot of kind of similar code, and this is, it's a pain for refactoring anything. It's a pain to add new features or to support new syntax, and you have this just unnecessary churn of having to keep the parser and AST up to date with what RustC are doing. The other downside of the Rust format approach is that it's always struggled with macros. The fundamental reason for this is that the compiler's AST represents macros after they've been expanded. But of course, Rust format wants to deal with the source code before the macros are expanded. And so you have this fundamental mismatch. And there's never been a really good principled way to handle macros. That's been getting better over the years, but it's just kind of an inherent weakness with the approach. Could we do better? Yeah, I think we could. Obviously, we learned some lessons, but we could do better now, primarily because now is a different time to then, and that means that there are different requirements, and that means there's a different design space. I would not use the compiler's AST. I would not really use any AST. I would have a custom representation somewhere between tokens and an AST. That is possible because we know what style we're aiming at. Like the Rust code style has been decided now. And also because I would vastly reduce the number of options that are available. Having lots of options makes, it's hard to test, hard to maintain, and also, we've established now that the Rust code style is good. People are mostly happy using it. And the less variance we get there, the bigger the benefits that we get. And life's better when you're a bit more tolerant, and the same is true of code formatters. Rust format is fairly pedantic about always squishing your code into the line width and meeting other constraints. And I think sometimes it's better if you don't do that. You just accept that some lines of code are never going to fit within 80 columns or whatever your limit is, especially with a bit of rightward drift of indentation. And it's better if that's 1 in 1,000 lines, just let it overflow. It's fine. It's going to look better. And especially if that means your code can be simpler and the tool can run faster, I think that's a good trade-off. And how about the process that we use for defining the style? I mean, I think the output is pretty good, like the defined Rust code style. I like it. I didn't when we started, or when we finished, I guess. And I think that points to a real success of the process, is that it did way better than certainly I would have done by myself, and I think better than any individual would do by themselves. On the other hand, wow, it took a lot of work. We essentially front-loaded every one of those horrible bike-shedded arguments about code style into this little process. And yeah, it took 2 years, which is a long time. And it took just a ridiculous amount of mental energy from everyone involved. So. And I think to evaluate the real... Is that a red flag because I'm done? Oh, sorry. Okay, I'll be very quick then. Yeah, people use it. It's great. I want to... yeah. I wanted to share why I thought that was. I've obviously run out of time, but I'm just going to say it was really important we respected community norms and values. We built trust both in the process and the tool, and we made it as easy as possible to adopt Rust format by doing things like making it easy to install with RustUp and easy to use with cargo integration. That is the end. Thank you for coming. Thank you for your attention. Wait. Yeah, please clap for all these people. None of this would be possible without all these people who contributed to Rust format and the process. So thank you so much. I'd love to talk about this more. I could go all day. Please find me and talk about code formatting, or find me on Discord. Thank you.